the second week, okay, this lecture is going to be the first lecture for our class, Design Computing. So please keep your eyes on the lecture slide. Actually, not only this one, but also your screen, okay? Now you know how to access local area network. Local area network, so-called LAN, okay? Local area network, so-called LAN, LAN, allows to access the other computers in the same area using same router system. In other words, our room has total 32, 33 computers, including my laptop. So all day connected. Also, one single line going to be getting outside of this building, outside of this city, country, in other words, to the world. That's so-called World Wide Web, okay, internet. But before internet, even within this boundary of this room, now you have network access. So why we need network access? Your course slide, now you can get how can get this file from the main computer here, okay? Here is a computer, main instructor's computer, and my laptop, okay? This screen is my laptop screen, but sometimes I can use this main computer. The computer name is 504, this room name, dash main, okay? Each computer has 504-01, 02, 03, 04, and so on, until 30. So your computers are one of them. They all interconnected, all connected anyway in this room. So why you need to access this computer? First, getting the file. Second, submit your lab exercise requirements from next week. Actually, today's lab exercise, we have done the first one, how to open local area network file, share the folder, okay? So probably some of you already know how to access LAN when you got middle school, high school, some classes, or PC방, okay, game room. You know how to access LAN. But anyway, this room has same structure. Now, later on, in any of my class, you can take advantages of such local area network, gigabps, really fast. The same as, sometimes faster than your USB drive, okay? Very fast and stable. Okay, anyway, this is one extension of our class titled Design Computing. The course name is CAD and Graphics. But last week I told you CAD, design computing, digital design, computational design, or even any other abbreviations in our domain, design computing domain, they all same eventually. That was my point last week. So today's topic is why, okay? Why? Why design computing? Why design computing? Okay. Actually, I brought this picture for fun, okay? You may recognize which one is Poppy's face or which one is Muffin, right? This one, Muffin, this one, a puppy, right? So who taught you? How you get that? Have you learned from your parents, your friends, your teachers, how to distinguish this muffin shape and the shape of this small dog? How to differentiate them, okay? You know this is muffin and this is puppy's face, okay? So you learned based upon some empirical way, okay? Your experiences, your kind of recursive daily life experiences are your good learning source, right? You saw amount of similar pictures of muffin, and you also have watched thousands of puppy face, right? Based upon such experience, you can easily distinguish them. What if you are kind of very small, little boy or girl who never seen muffin or puppy before? In that case, no way, okay? Cannot distinguish them. Okay, you learn based upon your experience, okay? Again and again, based upon your similar images. So how about computers? Nowadays, can computers distinguish those pictures? Have you searched by Google image search using specific keyword? For example, muffin. And then Google image search results will display amount of muffin pictures or muffin related pictures. Possibly those pictures can be popping up, but rare, not that many, okay? Computers cannot distinguish them in natural, in as-is status. In other words, before machine learning or deep learning method Google developed. Actually not Google, by scientists, engineers. But anyway, it's not 100% perfect technology, but at least Google image search has the function for distinguishing such things. Based on what? Based on algorithm? Of course there is an algorithm, but based upon their autonomy. In other words, machine learning technologies. Google can collect amount of muffin pictures, probably millions, right? Uploaded by users through Pinterest, Facebook, Instagram, and so on. Somebody took muffin pictures and they upload titled muffin, my favorite muffin, I love it, at New York, right? And Google can distinguish and recognize millions of muffin pictures, and they learn patterns, how muffin pictures can look like. Also, puppy face too. So computers nowadays learn very similar way to humans, okay? Humans learning process. So this is actually not very cutting edge technology. Several years ago, some genius scientists, genius computer engineers developed this approach. And that is why now you can search based upon your string for specific images, okay, without not that big problem, okay? So my point here is computing technology is kind of something beyond your expectation. How about this one? You know this one. This is very up-to-date issue nowadays, right? So you know AlphaGo. Do you know the meaning of alpha and Go? What is Go? Go is kind of international term for 바둑, okay? If you watched drama or comic book 미생, you may know 바둑 is kind of better term, especially for Korean. Anyway, this is 바둑, okay? The most complicated, sophisticated board game. There are too many ways to go in the game Go. And what is the meaning of alpha? Alpha means usually A. A means initial, okay? The first. In software industry, in software environment, we usually say alpha version. Alpha version means initial version, early draft, okay? Not mature version. Second version, probably beta version, beta test, okay? And publicly release, official version. If you are very interested in some game. There are some alpha test, beta test, and official release. Okay, so the term alpha here means some initial version. For what? For Go game. Okay, so this machine distinguishing part is this is deep learning based. Deep learning means something advanced machine learning, which means it learns by itself. It plays Go game, millions of games per day, several games just in 1 second, using thousands of computers, using cloud computing or some advanced technologies. So AlphaGo is a computer program developed by Google DeepMind in London to play the board game Go, only for Go game. But you know that the human champion, Isedo, has beaten until third games. But thankfully, I'm not sure today they have the match. But anyway, yesterday, finally, Isedo won a game, the fourth game. But anyway, overall result, Isedo lose the game, right? But anyway, it was very amazing event because most of experts, including me, has been expecting, obviously, Isedo is going to win because even if machine learning technology is very advanced, it's not that far reached until Isedo or someone like Isedo's capability, because Go game has really, really many diverse chances to be done at the end. Anyway, AlphaGo, the name AlphaGo here means, nowadays we can say, sort of godlike somebody for Go game, okay? Because it wins the game against human champion, one of the champions, Isedo. So this is kind of cutting edge technology in this domain, in this area. AlphaGo for Go. How about Alpha Chess? Actually, there was chess machine already. Human has beaten by something like this application, computer. How about Alpha StarCraft? Google mentioned that their next level test possibly can be StarCraft. Okay, so amount of Korean StarCraft champions going to be involved in this test someday. Alpha role, okay? Possibly there could be amount of similar applications, software they can develop. Here Google or some leading computing technologies people, okay? Some genius people. Okay, how about alpha design? Thankfully, fortunately so far, there is no such application, alpha design. Alpha design literally means a design machine in automation without help from designers, interior designers, architects, architectural designers, and so on. Someday, computer can design by itself. Why? It can collect billions of existing good designs in the world through the internet, okay? Pictures, floor plans, 3D views, layouts, special layouts, furniture layouts, specific material design, colors. It can learn by itself, okay? Actually, not right now, in 5 years, in 10 years from now. Anyway, what if alpha design, alpha architecture, or similar AI, artificial intelligence-based computer tools that can learn by themselves are learning building designs and interior architecture designs existing in this planet, even in this galaxy. bigger than millions of design cases. They learn all existing designs and they apply them to new building designs in automation. It's possible someday, okay, from 10 years, 20 years, or even just 5 years. And you know what? I'm the man who's working and researching in this area too. Now I'm involved in some AI-based design rule checking project funded by Korea government as well as some other funding resources. Something about AI, okay, for design. That is eventual goal of design computing. Are you sure you can design better than those machines, those computer software? What should we learn and study now? I know you are all freshmen, okay? You don't even know what is computer CPU, what is GPU. If you are a game lover, someone probably LOL lover, or at least you enjoy smartphone games, right? Internet games, web games using PCs or smartphone. In every single day, when you get into school, in the subway, you may playing game, right? So if you are a good gamer, you may know what is GPU, graphical processing unit, and you may know expensive GPU makes my computer game speed much faster, right? In that way. But most of you don't know what it is, how to use, how to deal with computers, because you are just users, consumers for computers. But from now on, you are here to do something for computers. Actually, not for computers, for human, using computers, okay? So, actually, my point here was just bringing your attention about this kind of cutting edge issues, cutting edge techniques. What is cutting edge? Cutting edge in Chinese character, it's 첨단, okay? 첨단, okay? Cutting the edge of the knife. It requires really highly advanced technology. In very low level, elementary level technology, no one can cut the edge of knife, okay? The knife here means really, really sharp and strong knife, okay? Not just pencil knife. Anyway, that simply means cutting edge. Up to date, the latest advanced technology means cutting edge, okay? So this is one of the cutting edge nowadays we are talking about. So computer technologies, they are really, really something beyond your expectation in your current thought, okay? That's my point. Possibly someday, alpha architecture, alpha design, alpha CAD. What if alpha CAD and graphics? This is the course named CAD and graphics. Now you're gonna ready for learning CAD and graphics. But there is a software, alpha CAD and graphics. They already did lots of CAD and graphics in automation, very faster and something better than you guys, probably in near future. So, do we need to study CAD and graphics? What should I do? What should we do? Okay, bringing another question from this issue. That's my point. Okay, take a look at this slide. This slide will show you what you're gonna learn this semester. Actually, I'm not gonna teach you entire things listed up in this slide. I told you before, fishing rather than fishes. I'm gonna encourage you to teach yourself, to learn by yourself from what? Books, internet web pages, smartphones, instead of playing game in subway. You can take a look some IT articles or some useful documents just in a couple of minutes every day. in order to get some cutting edge issues to take advantages of them, okay? So I like to encourage you, teach yourself, and highly motivated for learning something cutting edge and advanced ones. Okay, let's take a look at what should we know from this course or next series of my courses, all entitled under the keyword design computing, okay? All design computing courses, my courses. So firstly, fundamentals of computer science, computer engineering theory. I'm not talking about entire theory part. Some important things you need to know, okay? For example, some brief history of computer, brief history of computer engineering, how computer works, some behind the mechanism, algorithmic issues, something about that, okay? Computer hardware. Some of you may know well about computer hardware, but some of you may not know what is computer hardware. Some of you never opened the computers or never interested in such things. But you should know computer hardware because you're going to use computers for what? For design, for 3D rendering, for visualization. Okay, think about this. If you are a gamer, pro gamer, you need fast computers. Very expensive GPU and really high-speed, expensive i7 quad-core or hexa-core CPUs. For what? For better gaming environment. Computer graphics, same, okay? Game environment, computer graphics environment, very similar each other. So you need to get something expensive and faster hardware. That is why the computers in this room are really comparatively expensive and faster than other computer rooms' computers, okay? Really expensive computers here, actually. Your monitors are VR supportive. If you wear VR goggle, and then you can see virtual reality from these monitors, very expensive monitors, and very fast computers. Actually not up to date. 4 years ago, best computers at that time. But anyway, still they are really fast. Anyway, you need to computer hardware. You need to know why computer hardware will determine your final outputs, rendering speed, quality of your design. If you are just writers, you need only typing tools, Word, okay? Word processor. You don't need to buy expensive computers. Just very cheap computers are okay. Because you need type only, okay? But unfortunately, you need to know, you need to use very heavyweight 3D applications, okay? That is why you need to know computer hardware. So in our class, in the lab exercise, we're gonna open computers and I let you know what is main features you have to know when you buy new laptop, new computers for your major, for your design work, and so on. Next, network. You have learned a brief something about network, but that is almost everything about network, okay? Now you know 2 backslash, which means network access, okay? You can connect other computers, your friends' computers, remotely. You know internet, you use internet every day using your phone, smartphone, tablets, computers, web browsers. We're gonna learn something beyond things based upon your daily life, kind of joyful internet use, okay? I mean, something designers and university student level network or internet things you're gonna learn, okay? Light gray, something dark gray, another dark gray, computer software, operating system, especially Windows, okay? Some BIM tools, advanced tools, Revit, or some kind of very recently developed applications are mostly running on top of Windows. Of course, Macintosh, Mac OS X supports lots of computer graphics tools, but in our domain, we need to use something different. So we're gonna deal with the software mostly based on Windows, okay? Your Windows environment. What if your Windows show you blue screen, freeze? What if your SketchUp file freeze and you cannot do anything? Okay, you need to know at least a little bit about Windows, how to save, how to reinstall, how to fix the problems in Windows. You need to know. Why? In order to avoid unnecessary problems. What if you have created your design file based upon your 10-hour work, but it's freeze, down, blue screen? You need to know how to recover autosave files or how to save your files even if Windows have some malfunctioned and so on. But actually those things are something background things, okay? Supplementary. The most important thing in this black font here, computer software, especially some specific applications focusing on CAD and graphics too, okay? This is main subject, of course. The course title is here, CAD and graphics, okay? But not only CAD and graphics, but also some other things, including those things. What if the next phase is there? Even more things about design computing. Okay, I told you something about machine learning in very higher level, brief level. I don't know what is deep learning, what is exactly machine learning is working, but at least I can figure out how to use it, how to figure out the main aspects of machine learning, and I know what we can do based upon such technologies, okay? The same way you need to know in that aspects of advanced things in both design and computing, so-called design computing area, okay? That's my point. So you have to remember that aspects of design and computing issues. So quickly, actually those things are lab exercise part. So let me quickly skip the pages. After the lecture, I'm going to show you again and briefly have a lessons and some practices again. Just one thing, this is Google site. Under this site address, you can find out this course website. Actually, that's B. I'm going to let you know after the course. And access the network, some conventions. I'm going to show you this one again in the lab exercise hours. And also how to get free software for students using Autodesk community, especially for AutoCAD, 3D Max, Revit, and so on. Hundreds of Autodesk applications are very heavyweight. There are lots of applications, but thankfully all they are free for students, okay? So I'm gonna let you know how to download, how to get CD keys, how to get product key for your own personal student license for free, okay? So this is another lab exercise issue, and again, your convention, regulation in this class, in this classroom, okay? You need to bring your drive, your USB, your external hard drive, or at least you know you have to get some N drive, Google Drive, iCloud, whatever. You need online storage in order to save my given files for your further use, further study, later use, for midterm exam, for final project, and so on. Okay? Okay, Google site. I'm going to let you know this one in the lab exercise hours. Okay, someone is looking very sleepy. So 10-minute break, okay? 10-minute break, and then move on to the course material again for today's lecture. Okay, now we're gonna get back to the course material. Okay, let's finish rest of the lecture slides for today and then move on to today's lab exercise. Okay. So my question, are you ready for being a designer? Are you ready for being a design computing learner? Okay. Actually, the reason for asking this one is kind of for fun, frankly, but it's interesting. Let's take a look at this picture, okay? This one is kind of famous picture, turning this way or opposite way, okay? Anyone sees this one is turning counterclockwise or clockwise? Okay, anyone who is seeing this one in counterclockwise, I mean turning left when you see on top of this image, counterclockwise? Or okay, anyone who sees clockwise? Okay, that is kind of very common and natural because you are kind of right brain type, okay? But you know what? I never saw this one is turning clockwise. This one is always turning counterclockwise to my eyes, okay? I try to see this one is turning clockwise, seeing again and again, but never it turns right, okay? This one is turning only counterclockwise. Anyone, again, raise up your hand. Counterclockwise. Okay, so in Korean, in high school, there are 이과 and 문과. So anyone who 이과 or others are 문과? Okay. But actually I'm 이과 too, okay? And turning left, I mean counterclockwise is kind of this type, okay? Left brain functions and right brain functions simply listed up here. So let's take a look at left brain function, logic, detail, facts, word and language, math and science, okay? Math and science, knowing, acknowledges, reality base. Instead, in opposite way, right brain function, feeling, big picture, imagination, symbols, images, philosophy and religion, fantasy base, okay? Okay, so let me ask you next question. Which brain functions types are kind of designers' requirement? For designers, this part or this part, which one? Anyone who think this one is good for designers? No one? Okay, anyone who believes those parts are for designers? Raise up your hand. Who's not raising up your hands? Okay, again, designers should have those parts. No one? Only one? Are you sure? Okay, you are correct. You are the one who has you? Okay. Okay. Let's take a look at some highlighted keywords. Okay. This is kind of your myth. Okay. Someone who's designing supposed to be kind of using feelings, imaginations, symbols, beliefs, special perception, fantasy. But precisely say, you need to distinguish between art and design, okay? Take a look those parts. All they are good for artists, okay? Artist. If we are in fine art school and you are all painters or musicians or making something for artistic reason, artistic purpose, you have to be fantasy-based, very imaginary, something totally new. You can draw by yourself. You can paint anything, okay? Based upon totally human creativity. But for designers, what if you design in this approach? Your design probably very, very valuable only for you or someone like you. How about others? If somebody dislike your design, that is not a good design. Okay, design is supposed to be loved, not 100%, probably at least more than half. Okay. In other words, many people should like your design. That is design. So even if you are kind of pink lover, your furniture, your space, your products not going to be pink, simply because some people, mostly male people, okay, they don't like pink. So you have to design in blue, black, white, gray, and so on, instead of pink. Even if your favorite color is pink, if you are a designer, you don't need to use pink. But you can use pink as an accent color or some subcolor, whatever, okay? That's the approach of designers. What if you are a painter and you love pink only? You have only one color, pink. And then you can make your own world by pink, drawing everything by pink, typing pink in pink color, or typing red in pink, whatever. You can do anything. Totally open-ended world, okay? That is so-called art, okay? But again, design. How about building design, interior architecture design? What if your interior design is based upon fantasy instead of reality-based? You are not a game designer. You are not designing game environment, game characters. You are not designing monsters, okay? You are designing space for human in reality. That is why you have to design very efficient and simple and commonly loved features in your design. How to count, how to measure such commonality or popularity? Totally based upon some mathematical statistics or some scientific ways, okay? Not religious or philosophy based, okay? That's another really important thing about design. Your design is science, okay? Not on art or philosophy or religion. This is one really important thing you have to figure out at first, at the beginning of design study, okay? Okay, another one. Actually, this is my opinion, my idea. Most of designers still have this concept. They believe I'm an artist. I'm an something exceptional artist for most people. Someone believes some designers believe that he or she is an artist. That's okay. That's his or her belief. That's fine. If he or she generates really good design for every people, every individual, and everybody likes his or her design, that's okay. What if he said he's an artist? Even if he or she said I'm an artist, but he or she totally based upon this approach, okay? So my point here is, from now on, you have to be logical, okay? When you design your design process in your design studio, okay, my design concept is very sophisticated based upon religion or philosophy. My philosophy is invisible, cannot explainable. You have to accept my design anyway. That's ridiculous. That means anything. That means nothing. Totally bad design or bad presentation about your design. But what if you say, okay, my logic is here. Children's love very small space to hide. So I made this furniture has some intervals, gaps, in order to hide between those things. And then kids gonna love this furniture and small space. Very logical and scientific, okay? And that approach going to be really kind of valuable to owners. And then they will buy your design, okay? Very, very simple. So that is why designers are supposed to be in this area. But unfortunately, you are freshmen. You just finished Korean SAT examination for being a university students, and your types, your kind of typical manners, attitudes are totally based upon this area, I think. Another thing, in my personal opinion, those things are kind of easy, okay? You can get all these things comparatively easier. Okay, say something about philosophy. Say something about your feeling, your big picture, your imagination. Whatever it is, comparatively easy if you can say Korean or English, whatever. You can say anything. But you can say something of those in 10 hours, okay, without break. It's possible to all of you. What if you have to say something about science 10 hours? No. Even if you majored equa, you don't know, okay? You don't know how to explain this mechanism in mathematical and logical way. That's not that easy. It's totally kind of long-lasting effort-based training you need. Okay, think about medical schools students. They study all this part all the night, every day, okay? But what happened in your design studio room every night? Chicken with beers, listening music, doing something, okay? Talking with your friends very freely, easily. But someone for studying this area, take a look what they are doing. They really concentrating on very thick English books to study, to research, very hard, okay? Use their brain, not your feelings, instant feelings. I'm not talking about our design things or your design study or your artistic approach is bad and this is good. I'm not talking about that. I'm talking about some difficulties in reaching a certain level of level bar, okay? Certain level of standard. Okay, except me, except my course, or other design studio course, you need those parts, okay? So every other instructors going to say something about those issues. You should be creative. You should be very orally plural to say some of your concepts. You have to very philosophy based and fantasy based in order to make your dreams true or your concepts make it realistic. And you have to use your imagination and so on. Okay? Except me, all other professors, instructors going to say all about those things. That is why I like to put more emphasis on this part. Okay? And think about this course. What is geometry? You're gonna learn geometry and topology, okay? For what? For CAD and graphics. What is a line? There are two vertices and their vector connection going to be one single line. At least 3 lines enclosed going to be one polygon. One polygon means one planar surface. How about those collection of surface? What is that? That is 3D surface, okay? 3-dimensional means X, Y, Z Cartesian coordinate systems, mathematical calculation result. So we are going to deal with some computational manner of CAD and graphics. That is why I like to put a lot more emphasis on this part. That is why you have to use left brain, at least in this classroom. For what? For computers, but not only for computers, also for design. Design is science, okay? That's my really important point for you guys. But most of you very familiar with this part already. So we don't need to study this part, train this part again and again. You have to train this part, okay? Mathematics. Even if you don't know mathematics, don't worry. We need to get very earlier part of your famous book, 정석, okay? Discrete mathematics, logic, set theory, graph theory. That's enough. Of course, we need even sophisticated and difficult things for resolving computer graphics issues, but we're not gonna get that far. We're gonna deal with very fundamental things and your fundamental theories for computational design, CAD and graphics. But, but the conclusion here is not only this part. My conclusion here is actually both, okay? You need to get logic and sensibility. You have to be fluent in language as well as images, of course, and you have to be scientific. Also should be conceptual, okay? Also you have to be practical and imaginary, okay? Blended, something merging, okay? That is good and important point. Using what? Using design computing, okay? So the nature of design computing, we can say you need creativity, okay? Not just simple creativity, so-called design creativity, digitally augmented creativity, okay? Try to think totally different using computers. You can think different without computers. But now it's time to know, now it's time to learn how to think different using computers. If you know computers very well, you can create something new thanks to computers, okay? Without computers, you couldn't even try to do that. But after learning computers or advanced things on computing powers, design computing technologies, you can make something new, okay? That's my point. So use both brain functions, left and right, but put more emphasis on left. Reality-based, mathematical, scientific approaches. That's my point, okay? Use both. Okay, let's take a look at a real-world project, okay? One case, one example. Just as a preview of your design studio in the future, in very near future, okay? We're not going to deal with the computer software right now. Next week, we're going to do something using computer software, hardware, environment, and so on. But today, I'd like to show you what should you do in near future using computers. That's why I'm going to show you one case, example. Hanyang University College of Human Ecology, our college building, this building, okay? This building has been remodeled 3 years ago, okay? 3 years ago, in winter break, in 3 months, totally renewed. So those pictures are kind of before picture, okay? When I get back to Korea, 2012, the building was looking like totally same to this one. But after 1 year, this one remodeled. Exactly same, the building now. As you see, this building at first, at the beginning of early phase of this year, this is kind of after, okay? But before remodel, before reconstruction, it looks like this. Anyway, at that time, I was the member, one of the members for planning, designing new building, okay? So me and our department professors, Professor Hwang and Nam, and also famous designer Professor Jang Sun-gak, professor, we are involved in designing the buildings. And I designed some spaces and things, and I'm going to show you. Especially women's restroom is way better than men's restroom. Male toilet is totally looking typical. You don't know how it look like, but anyway, it's looking very typical. But as you may know, women's toilet, I mean restroom for female is really beautiful because I designed it, okay? Compared to other buildings' female restroom, this building's female restroom is small, but very decent, okay? Because I put lots of efforts designing something better than other buildings' restroom for female. So you have to recall that. Anyway, let's take a look at some cases. This is before floor plan for this floor, level 5, okay? This is computer room, but at that time some split rooms for research area and offices. Take a look, this is CAD drawing of after. So this is computer lab. Now we are in this room, okay? And this is VR screen. Now I'm standing around here, okay? And elevator halls, vertical penetration, building core, including this stairwell and our college library. But this college library also going to be updated soon. This one going to be removed and some cafeteria, student meeting room space going to be newly installed. Something like Starbucks, coffee bean area. Not right now, I'm not sure when, but anyway, soon to be updated. And this is my office, okay? You can stop by my office, 511. Anyway, this is our new plan. At the time, what did I do for design planning and visualization? Actually, I use this kind of AutoCAD file too, but we don't need to use AutoCAD. What we need to do is visualize new layout, new design, not very sophisticated 3D shape of design, okay? The most important thing was new layout and new features or new furniture layout, quantity of furniture, desks, chairs, location of computers, offices, and so on. So at the time, I used PowerPoint, okay? I used PowerPoint and Photoshop for design. We don't need to use AutoCAD, 3D Max, SketchUp, or even more professional tools. It's good for our objective at the time. For better visualization, effective and efficient way, I find out PowerPoint or Photoshop is way better than other professional tools. Even if I'm an expert in using such tools, but I use the PowerPoint. Let me show you PowerPoint examples. All those are PowerPoint based because we have given existing floor plan, images or CAD files, so we can put some new allocations, new layouts based upon existing plans. And plan room by room plan, new plan, okay? This is room 507, okay? 507. This is computer lab. At the beginning, the layout design was something like this, but updated again and again. At least at the end, this room has designed and actually installed like this. Our department device room and 501. And what is this? This is level 6, okay? Here is our department student hall. This one has desks and some tables and TV screen and college common lecture room and some offices, exhibit studio and other students' studio room, okay, lecture room and so on. This is level 6 and floor by floor design as well as room by room layout design done by PowerPoint. This is PowerPoint. At that time, I presented this one to other faculty members or someone who's in charge of this remodel. And we got communicate each other for better environment. At the end, remodeled, okay? All those are the same slides that I used 3 years ago. Exhibit, studio, and 608, 7. Based upon such visualization, design, and planning, we made actual remodel. Let's take a look some real pictures 3 years ago. Removed the curtain system and removed the entire window system. And this is our first lobby back door, okay? Back gate. Actually, this was opened before remodel. As a result, College of Music and other college students always passing by our lobby. Crowd, okay? This building is crowded enough because of the dining room on the top floor of this building. So for some reason, for our students' convenient access, we installed this type of, this is door, but we never opened this door, okay? If we open this door, this one can be folded and totally open area. And then amount of passengers going through our lobby, too crowded, and some energy efficiency reason, too cold or too hot. So we determined to install this type of door, okay? Very brilliant, isn't it? Anyway, this is the back door of our first floor lobby, and this is the corridor of this floor, okay? College study room and outside, curtain system. And my office under the construction. Take a look, this elevator hall. Take a look, conventional concrete surface, just so-called cement and painted. But take a look, L-shaped hanger, piece, and this stone surface going to be attached like this way for renewing interior surface. Take a look. So this is inside the structure of that elevator lobby in the entire this building. So before installation such surface finish material, stone material, this is first floor lobby, and this is after, okay? Stone and new fashion kind of new rail bar for the second floor, but same ceiling structure and something different. And this is 507, room number 507, okay, before installing furniture. Okay, all these are pictures, and let me show you some more examples using pictures and some 3D images, just computer generated or some reference images. Sometimes reference images are very powerful for new design. Anyway, more examples of design and planning. Why we design, why we plan. Okay, you need to know at first, the most important reason is preview. Okay, preview what? Previewing of design before realization, before construction. So why you design? Why you need to know computers for design? Because owners, users have to see what's going to be happened before real construction, real installation, okay? So-called preview. One of the important reasons of design is preview. In other words, visualization, your ideas, okay? So most of your work using computers are going to be design visualizations, design presentations, okay? Over 90% of your work supposed to be design visualizations, design presentations, design representations, okay? Anyway, take a look. Take a look those lines. This is our basement floor's floor plan. Take a look the lines. They are all vector lines, but not AutoCAD lines. I draw those lines using PowerPoint line drawing tools, okay? You can simply use line drawing tools and controlling thickness, colors, array, and copy and paste, and so on, much faster than AutoCAD or other professional tools. Of course, I can use AutoCAD, SketchUp, 3D Max, even complicated tools. But at the time, I can draw door symbol using PowerPoint drawing without any problem. That's easier at the time. And I Googled auditorium desks, chairs, some alternatives, and we discussed about that. So at the end, something like this one installed, okay? This is basement 106, Hacker Hall, okay? While constructing the base structure. And this is the picture before installing chairs, okay? And then at the end, this is the as-built picture. So for making this space, this type of visualization, representation sometimes was good enough, okay? We don't need to make 3D Max-based photorealistic 3D rendering or walking around. Sometimes we don't need to do that, okay? So drawing something like this is going to be one of your subject for lab exercise. Next week, next step to next week, I'm not sure, but I'll let you know, okay? Okay. Another example is our first floor lobby. This is original plan. This is our main gate. This is level 1 floor plan. Here is administrative offices, elevators, and back doors, but this one actually closed. But anyway, take a look. Some chairs and very typical tables. But we abandoned this idea. We tried to make something different, and I made this roughly measured, actually not roughly measured, totally based upon existing CAD plans, and I got those dimensions, numbers. And take a look this. This is reference image, okay? Reference image, but we try to make something similar to this image, okay? Or this something like this. But actually, eventually, we used something like this furniture at front level, lobby. But some students moving those furniture here to there, close to the wall, and something is missing, stolen, or somebody moving that onto other offices. And that's what you saw this morning at the first level lobby. But anyway, original design was something like this, okay? And also the couch, sofa, and the furniture placed in our lobby, actually they are kind of expensive and good material, okay? Good furniture. The last case is this one. Do you know the name of this structure? Usually placed on front gate, front entry. This is canopy, okay? The canopy without college signage. We need this kind of signage. So this one is another topic for your lab exercise. Using what? Using SketchUp, okay? You're gonna make this canopy and you're gonna make this kind of thing. At that time, this is my proportion, okay? My dimension and proportion, height, width, depth, thickness. And this is Hanyang University college font, okay? Not old font, new font. But actually, I don't like that font, but we have to use this font for UI, University Identity, something integrated design approach. And college name in English, okay? So I made this one at that time using just a SketchUp. We don't need to use very complicated professional tools. So I made this one using SketchUp and give that to manufacturer. And they made it and installed. And now you see this signage on top of this canopy. One tiny, small example, but anyway, now you are in charge of making something like these things, okay? For realizing this structure in real world, okay? Wake up, okay? Okay, we have walked through some cases, real examples. For what? For design representation, design visualization. So what types of visualizations we have? Before handling our main subject, let me quickly show you one advanced example, okay? Advanced CAD and graphics. This is CAD and graphics. We're going to deal with CAD and graphics. But you need to remember, you need to note that advanced CAD and graphics is building information modeling approach, BIM. Actually, this is my major, okay? I'm mostly working on this part. College of Human Ecology Building Remodeling designed by Revit. Revit is computer tool name, Autodesk Revit. Let me show you quickly about that. Okay, let's take a look at this application. Is this looking professional? Actually, this is kind of cutting edge and very commonly used advanced tool named Autodesk Revit. And you may recognize this building is our building, okay, in 3D. For designing this building, let's take a look. This is professional CAD drawing. For what? For that window, okay? We have amount of this window system. Take a look. Fan and 2 above windows and 3 windows, and those 2 windows are moving to center, okay, to the middle of this structure. So this is drawing, conventional CAD drawing, okay? Based upon this CAD drawing, in advanced BIM tool, we are not going to draw. Instead, we model, okay? Modeling. Advanced BIM modeling for the Windows system. So, take a look. Numbers, parameters, and equations, and its names, properties, relations in 2D and 3D. At the end, 3D geometric shape modeled. This one has information about this Windows system, okay? So this model can have some alternatives. So this component can be placed onto your 3D building model, not just copy and paste this kind of 2D visualizations. So take a look. This one single component can be easily attached to the wall, something like Lego blocks, okay? Something like game. So they can easily arrayed and attached, modeled, placed, or removed easily and intuitively. At the end, much better 3D BIM model, much better than just drawing, okay? This is one good preview for you guys. But unfortunately, we're not going to deal with this kind of tools now. You may learn this one for semester, second year, and third year in my class, okay? Currently, third year students in my class, digital design and BIM, in that course, their main subject is this tool and a lot more applications. But in this course, let's take a look what we are going to do for this class in this semester. At the end of semester, I'm gonna show you from now on what you're gonna make, okay? Conventional design representation plus conventional design computing, so-called 2D drafting, but not only 2D, but also we're gonna deal with 3D. Especially for interior architecture design, 3D is another very important thing. So we're gonna learn 3D and 2D. Let's take a look what types of visualizations we need. Take a look this blueprint, hand drawing. Amount of hand drawings, too many hand drawings. All these are conventional before computers. Amount of drawings, drawing types are here. Site plan, floor plans, elevations, sections, and 3Ds. Isometric, axonometric, perspective, line drawing, renderings, photorealistic renderings, shaded renderings, and so on. They are all industry standard, okay? Industry, they use this type of drawings and images. They are all symbols. You have to know symbols. That is why you are taking another course, hand drawing, hand drafting course, okay? Because you are freshmen, so you need to know what are those, okay? You don't need to train how precisely and how fast I can draw by your hand. You don't need to get that kind of skills, okay? Instead, you have to know what are these? What is industry standard, okay? But thankfully, this is design computing course, so you're not gonna use your hand drawing. Even if you draw by your hand, you can scan it or taking picture and load your computer. After that, that's going to be CAD, digital design, using Photoshop or any others. Okay, let's quickly look at visualization types you have to learn. You have to produce, okay? Produce. In general, the course title name 101 means the beginner's course. So now it's time to get produce 101, okay? not that TV program, TV show, Produce 101. The meaning of that Produce 101 also same, okay? Produce Girl Group 101. But anyway, it's time to take that course, Produce 101. Produce what? Produce something like this, okay? For your design. Okay, site plan. Take a look, site plan. Computer generated site plan has landscaping, contour, compass. What is landscaping? Trees, foliages, green, grasses. Contour means contour, okay? 등고선, okay? Compass, you know what it means, right? This is not number 4, north and south, east and west, okay? That's compass. Another example, more examples, black and white. Sometimes we have shadow casting. Take a look. Black color here means shadow casting, casted shadow. That is why, okay, this shadow is really long casted, which in other words, this is really high rise, okay? So this type of site plan visualization also required. You need to produce something like this in this semester, or especially in your studio course in near future, okay? Okay, floor plan. In general, dark black part means solid wall, okay? Walls. Void part, of course, void area. In other words, rooms, spaces, okay? How about those things? Foliage, trees, okay? Landscape. It contains exact components of plan, line depth, dimension, scale, pattern, furniture layout, and so on, okay? More examples. In this case, furniture layout, okay? Another one that I showed you before, the plan for this floor before. Okay, elevation. Elevation shows you contour as well and height dimension. This is contour, okay? You know where is kind of upper place, lower place. Okay, what is this? Why the designer put this tree here? Why there is a tree? To make this building is kind of nature friendly, or what? For what? Actually, in this plan explanation, dimension, okay, scale, okay, you know the height of tree. You don't think tree has 100-meter height. You don't know, you are not saying tree going to be 1 meter height. Tree has, in general, 2, 3, 4, 5 meters, okay? So thanks to this tree, you can measure roughly the height of this building. And mostly there are some people, okay? Women, sometimes a dog, kids, men walking around. Thanks to such dimensions, we can measure comparative scale, okay? Without those trees, it's not easy to figure out this height is 10 meter or 50 meter or just 3 meter, okay? It's not easy. So that is why we usually put the tree or human or something scale objectives, not just in this kind of elevation, also floor plan too. There is people or tree or tables, sofa, whatever, okay? Or stairwell. You can figure out the scale of that building plan and so on. More cases of elevation. Also there are trees. Okay, now 3D. This is so-called 3D wireframe. Wireframe means all drawn by lines. Lots of lines, okay? This line drawing 3D has created in 1976, made by Professor Chuck Eastman, my advisor, okay? When he was young, actually not that young, but anyway, at the time, he kind of one of the men who created 3D using computers, okay? Very initial phase of CAD, computer-aided design. This is wireframe. And this is actually another type of line drawing, but this is not wireframe, actually not wireframe. This is hidden line removal. Hidden line removed 3D line drawing. Okay, behind this rail, it's invisible, simply because it's really invisible, okay? But this one all visible. This is just wireframe. This is kind of realistic perspective. Another case, looking very professional. Sometimes just line drawing without any colors, any shade, or any additional features. Sometimes just line drawing is even looking professional and powerful for visualization. So you need to learn how to make them, how to get maximum effect from your visualization for your design ideas, okay? I don't care what is your idea. This class doesn't care your ideas, okay? We don't have time for developing your ideas, but some of your ideas anyway. But our focus is on what is the effective, what is the maximum power of your design media, your computing capability or understanding computer tools, specific features. 3D rendering, this is rendering. Take a look. This shadow, in Photoshop, you can fill gray colors, but that is not a shadow, not real shadow, that is fake. But in 3D, this shadow casting precisely calculated by real lighting source and real shade casting. So that is why we are saying 3D. But line drawing looking 3D, okay? Another type of 3D, but this one is looking realistic. Another photorealistic case for the building, CCTV building in Beijing, Shanghai, I'm not sure. But anyway, that's the real building designed by HOK and realized in actual site, okay? How about this one? Also, this is looking sort of realistic, but this is rendering, retouch, okay? But this is real-time render, something like game. Take a look. Google logo is here, which means this is Google Earth, Google Map, okay? In Google Map, Google Earth, you can find out real-time 3D buildings like this way. As you know, as you may know, Google already scanned entire this planet. Google already scanned using their airplane, drones, and satellites. They took all the pictures of this level of detail, buildings, entire city, entire area. Nowadays, what they do, they are invading into inside of the building. Now they are scanning interior. So possibly your future competitor could be Google, unfortunately. Google Genius now interested in inside of the building. So now they are collecting interior geometry using their smartphones and laser detectors and amount of sensor devices, okay? That is Google Tango project, scanning inside of the building. What if you have very detailed inside building geometry of Louvre Museum at Paris? You don't need to get there. You can take a look in VR, something really realistic way without visiting Paris, okay? Is the Louvre located in Paris? Correct? Okay. Anyway, rendering, real-time rendering. If you are a game lover, you know how game rendering environment technology is advanced nowadays. Really, really fast and realistic. Cannot distinguishing from real-world pictures. Driving, automobile driving, or airplaning games looking very realistic. Okay, anyway, this is kind of cutting-edge technologies you can use. You can take advantages of your design, your idea, development. Okay, the last case. Take a look, this example. Okay, you can find out chairs, tables, okay? And the chunk of those blocks are kind of rooms, okay? And what is this? This ribbon looking object. Take a look this one. Oh, you find out tables, chairs, and some red colored structure is swirling around in this space. Okay, thanks to this is not a picture. This is computer generated 3D image, okay? Thanks to this picture, now you can figure out, okay, this is kind of very specialized interior design element, interior design feature. And now you see, okay, this feature is going all around, almost all around of this interior. And this is real picture, okay? Structure really installed in this way. Can you imagine what is this? What's this? What is this? Okay, next question, or one clue. This is Chinese restaurant designed by Jay's Working. As you know, Jay's Working is Professor Jang Sun-gak's office. So this is one of his company's designs, okay? The reason I bring this one is, take a look. This is picture and 3D images and floor plan. What is the good thing from this floor plan? What is the good thing of 3D images? Simply say, if you want to know how many chairs, how many dining spaces, or exact layouts of this restaurant, you're not going to see this 3D. You have to see this floor plan, okay? That is why there is no such ribbon-like red color structure here. If that structure visualized in this floor plan, this one looking noisy, very dirty, and not that effective in visualization. This floor plan has very powerful features in layouting, representing this kind of things, okay? What if you want to see that red color accent object? In that case, you need to make this kind of 3D visualization. In this 3D, intentionally, all other unnecessary features are just blocked with white boxes, okay? Because it's effective. We can find out the mass of this building interior and structure of this one. By the way, what is this? What is this? What is this? This is Chinese restaurant, and this is main gate of this restaurant. In front of the gate, customers can find out this one on the wall. Bowl, chopstick, and noodle, okay? This noodle starts from main gate and swirling entire interior of this area, okay? So this is noodle, okay? The reason I bring this picture is this is really, really effective to show you how to visualize its concept, and very, very simple but powerful concept. Red color, very exaggerated and emphasized, okay? Without those structure, that one is still good restaurant, good design restaurant. But thanks to this structure, it has very, very unique feature. And that unique feature can be represented not by this floor plan. Thanks to this 3D computer rendering, we can recognize. So that is why the owner of this restaurant liked this structure, thanks to this visualization. And thanks to this floor plan, he or she, owner, can measure how many dining areas we can provide and how much money we can earn based upon this layout and so on. So they have different reasons, different aspects to visualize design. Okay, digital creativity again. I showed you this one before. This one still, to me, to my eyes, turning counterclockwise. But some of you, most of you, see this one is clockwise. Anyone who see this one counterclockwise now? Don't lie to me, okay? Okay, intentionally you try to make this one turning counterclockwise. You have to see this one is counterclockwise, okay? Now you see this one is clockwise because you are familiar with these right brain functions, because you are all freshmen. But I told you, you have to train this part, logic, mathematics, scientific, logical, knowledge, and orders and patterns. Design supposed to have orders and patterns, okay? Not disorder or fantasy. You can put those things as an accent features, but not main features, okay? Take a look, the 하인 선생, the design done by Jay's working that I showed you today, noodle. That one has very ordered, patternized layout for dining area. But one accent feature, noodle, in something fantasy or something very imaginary and images, symbolic. Just one thing, that is enough. All others are totally mathematical and scientifically planned in order, okay? That's, we say, design, okay? Not on art. Okay, that's the point. So we need to take both, that is design computing. You should be creative for being a good designer. That's my point today. Don't lose your creativity even if you learn design computing. Such creativity could be called digital creativity, digitally augmented creativity, okay? Without computers, you can draw you can visualize, you can present your ideas, your creativity by oral speech or your hand drawing, hand sketch, or your writings. You can write down about your ideas in 10 pages, 1 pages, whatever. But from now on, what you need to know is model something to represent your ideas using what? Using computers. Before alpha design released, okay? You supposed to be better than them based upon your digital creativity or just human creativity, your own identity. So AlphaGo really a big threat against human. But don't worry. This is yesterday's picture. You know what? I prepared this slide yesterday. I'm really, really proactive and very eager to make course material. That's why I put this picture. This picture taken yesterday, okay? So in this picture, Isedo, and I forgot the name, the CEO of DeepMind, Google, Isidore won the first game finally. What if it is due to a serious mistake of AlphaGo? You know what? Google mentioned that AlphaGo made a serious mistake and it lose the game. Can it trust artificial intelligence computers than human? Okay, take a look. From a reporter from NHK asked this one. So they got kind of dark face after got this question. Okay, this is kind of relief for you guys. Okay? No worries. Even if there is AlphaCAD and graphics, Alpha design, Alpha interior design, whatever. Based upon your study, your research for design computing or design, you may be better than computers. Even if I'm researching, now I'm developing something like Alpha design in my research project, that's just very initial stage, okay? Not in near future. So that's why you need to study about design computing and design issues, okay? At the last slide, I like to show you again what you have to learn, what you have to teach by yourself, okay? Okay, this is the last slide today. So we're gonna have another quick break, probably 5-minute break, okay? 5-minute break, and then move on to the lab exercise, okay?